parabolas and quadratic functions. And if you recall, in our first video tutorial of the series on quadratic functions, we talked about a very simple quadratic and finding the roots, the vertex, and the y-intercept of a simple parabola or quadratic function. And what I wanted to do was to build on that by giving you another problem or showing you how to work through another problem, which is a little bit of a variation of the previous problem. And that's what I hope to do in this series of videos, of giving you some exposure to a number of methods to use to solve and to tackle problems, because in a lot of cases in mathematics there isn't always just one way to solve a problem. There are many ways, and when you get into the real world, for example in science or engineering, there are often multiple ways to solve a problem, and in some cases there's better ways and quicker ways, and in other cases a little more elaborate. So right now we're just building a tool set. So let's try to tackle this this parabola. Y is equal to x squared plus 8x plus 15. I'm just going to change my pen color here just to make it a little bit brighter. But let's start by finding the roots of this parabola. And one method that we can use right away is the factoring method. And as you might know, not all parabolas or quadratic functions are immediately factorable, but in this particular case actually it is. And what we can actually find in this case is two numbers that add up to give you an 8 and multiply to give you 15, and we can try two numbers which are 3 and 5. If we just check, 3 plus 5 gives us 8, 3 times 5 gives us 15. So we found the roots of this parabola, and we can rewrite our parabola in the form, in factored form, x plus 3, x plus 5. And so how do we find the roots? Well, it really boils down to where this parabola or quadratic function intersects the x-axis, and where the function intersects the x-axis our y values actually equal to 0. So what it boils down to is solving this equation, or finding the x values where this equation is satisfied, and it boils down to separating this into two separate equations. X plus 3 is equal to 0 and x plus 5 is equal to 0, because if we see that if x plus 3 is equal to 0, then 0 multiplied by this factor here will just give us 0. So we found a root. And if x plus 5 equals 0, then that is another root, because if we take x plus 5, make that equal to 0, multiply it by this term, we'll get a 0. So what it boils down to is solving these two separate equations, and x plus 3 is equal to 0, or x is equal to negative 3. The negative 3 plus 3 will give us 0, so therefore x equal to negative 3 is a solution of this little equation here. And in this particular case, x is equal to negative 5. And negative 5 plus 5 will give us 0. So the roots of our parabola or quadratic function here is negative 3, negative 5. And so let's try to put that on a set of axes just so that to help you to visualize how this parabola is going to look. And let's use a couple of different colors here. So let's put negative 3 and negative 5 on our graph, and let's make this negative 3, and this is negative 5. And so our parabola is going to pass through those 2 points, and our vertex is actually going to be at this point right here. And how do we know to draw the parabola upwards? Well, that's another property of parabolas in standard form, is that if we notice the number over here in front of our x squared term is just a positive 1, and if that number is positive, well, our parabola is going to open upwards. But what I wanted to show you here, in our last tutorial, we found a pretty easy way to find the x coordinate of our vertex, and this point here is our vertex. It's really just the halfway point between the x-coordinates of our roots. And that's just using the property of symmetry. And so right here, just by inspection, the number which is halfway between -3 and -5 is -4. And so the x-coordinate of our vertex, the x-coordinate of our vertex is just -4. And what is our y-coordinate? Well, we're going to take that -4 and we're going to plug it into our quadratic function. F of x is equal to x squared plus 8x plus 15. And we're going to take -4 and plug it in. So f at -4, wherever you see an x, you just substitute -4. So -4 squared plus 8 times -4 plus 15. And anytime you square a negative number, you're just going to get a positive number. So -4 squared is just 4 squared, which is 16. 8 times -4 is just minus 32. And we add 15. 16 minus 32 is just -16. And if we add a 15, that'll just leave us with a -1. So the y-coordinate at our vertex is -1. And there we go. That's where our vertex is. But what I wanted to focus on in this tutorial is to give you another method in your toolkit for finding the vertex of a parabola. And that other method is called completing the square. Completing the square. And so if we rewrite our parabola x squared plus 8x plus 15, what we're going to do, and just bear with me, I'm going to just take you through a series of steps. What we're going to do is we're going to take this 8 and we're going to divide it by 2 and square it. What does that give us? 8 divided by 2 is 4, and when we square it, it's going to give us 16. And really that comes from a property of perfect squares, because, for example, let's take a very simple example, x plus 2 all squared. Well, if I were to expand that, we would get x squared plus twice the product of x times 2. So really that's going to be 2x times 2, which is 4x. And then we square the last term, which is 4. And what we find always in the case of perfect squares is that if we take this number here in front of the x term, divide it by 2 and square it, we'll actually get the last term. And so just to test this out, if we take 4 divided by 2 and we square it, we'll get 4 divided by 2, 2 squared is 4. And that number equals that number. And so what I'm trying to do when I complete the square is to rewrite this quadratic function and to get the first 3 terms in the quadratic function as a perfect square. And so what I'm going to do is I'm doing a little bit of a trick. And so what I did was I took 8, divided it by 2, and got 4, squared it, and got 16. And here's what I'm going to do. I'm going to take my x squared term, I've got my 8x term, I'm going to leave all the terms which I previously had in place, but I'm going to add that number 16, which I got over here, and then I'm going to do a little bit of a trick and subtract it. And so I really kept my equation balanced because I haven't added anything to the right hand side really, because 16 minus 16 is just 0. But what you'll see here is this allows us to write what we've written, this first 3 terms, as a perfect square. And so now what we can do is write that as x plus 4 squared. So x plus 4 squared is really just x squared plus 8x plus 16. So that takes care of these 3 terms, and then we're left over with negative 16 plus 15. And finally, negative 16 plus 15 is just negative 1. And so we were endeavoring to write our quadratic function in vertex form, which is just the general vertex form of a parabola is ax minus h squared plus k. And that's the vertex form of our parabola. I'll just label it like that, vertex form of a parabola. There are two forms for a parabola. There's a standard form and the vertex form. And the special property of the vertex form is that this number h and this number k as a set of coordinates, hk, is really the coordinates of the vertex. And so, kind of like magic, we found, using completing the square, the technique of completing the square, we were actually able to rewrite our parabola in vertex form. And just as a last step, to make it extra clear, x plus 4 can be rewritten as x minus negative 4. X minus negative 4. And negative 1 could be written as plus negative 1. And so now our negative 4 is just our h, and our negative 1 is our k. So our hk, the vertex of our parabola, is just negative 4, negative 1. And of course, we already knew that because we used the property of symmetry to find out that vertex actually really simply. But I wanted to illustrate to you the property of the technique of completing the square will actually get you to the same answer. And hope you find this tutorial useful, and we'll see you again soon. Thank you.